Welcome to variation of parameters. The method was started by Euler and then it was finished by Lagrange. And Lagrange is the same Lagrange we know and love from Lagrange multipliers. The method requires quite a bit of calculus. And so here you can see I've listed for you some Bible formulas and integration tips that will help you as you go through your homework. All right, the reason that variation of parameters is slightly more versatile is that it can be used to solve differential equations that have variable coefficients, whereas recall, undetermined coefficients, that's UC, could only be used for constant coefficient equations. Now I know you can all read, but I'm going to walk you through the steps of VP and point out some important things along the way. When you're solving a second order linear differential equation using variation of parameters, the first step is to make sure you have a monic polynomial. That means the coefficient of y double prime is 1. Now the reason why that's important is that will determine your f of t. Then you're going to find a fundamental set, y1, y2, for the associated homogeneous differential equation. Now it doesn't matter how you label y1 and y2, but it does matter that you stick to those labels throughout the solution. Then you're going to compute the Wronskian of y1 and y2, and at this point you'll have a list of 4 functions. You'll have a y1, a y2, an f, and a w. Step 3 is to use those 4 functions to find 2 more functions, v1 and v2. Now the formulas that I've given you here don't really appear in your book. Your book doesn't make it so easy to find those functions, and so here they are for your easy reference. And then step 4 finally is to put the v1 and v2 together to form a particular solution by using this formula here. Now this is where variation of parameters gets its name. The v1 and the v2 are functions of t. They're not constant functions. And I've got a justification of this formula on the last page. All right, and so even though we haven't started, we're going to look at a summary of the 2 methods here for solving a second order differential equation. So UC is undetermined coefficients, VP is variation of parameters. Kind of math that the method requires. Well, UC we've seen requires a lot of algebra. Variation of parameters is going to require, as we'll see, a lot of calculus. Restrictions on P and Q. For UC, P and Q must be constants. For VP, they can be any continuous functions. Restrictions on the driving function f. Well, again, for UC, there were quite a few restrictions. F could only be a polynomial, sine and cosine, exponentials, or a finite sum and product of those functions. For variation of parameters, it's just any continuous function. Okay, so let's look at some examples. In this first example, I want to use VP to find both a particular solution, yp, and the general solution to this differential equation. Now you could use undetermined coefficients on this because the coefficients are constant and the driving function is e to the 3t. So when we're done, you might want to try UC on that and see that you get the same answer. Step 1 is to make sure you have a monic polynomial. That's done. The coefficient of y double prime is 1, and so now we can determine our f of t. F of t is this function right here, e to the 3t. Step 2 is to solve the associated homogeneous differential equation, which I've started us out. This is the associated homogeneous, and I've written down the characteristic equation and I've factored it. Our roots are -1 and 2, and so our yc is c1 e to the negative t plus c2 e to the 2t. Now a fundamental set is e to the negative t, e to the 2t. And the order doesn't matter. I'm going to let y1 be e to the negative t and y2 be e to the 2t. You can change that order, just you have to make sure you stick with it throughout the whole solution. W is the Wronskian. I'll remind you how that works. You put y1 and y2 on the top row and their derivatives on the bottom row. And then you take the determinant. And so that gives me 2 e to the t minus negative e to the t, which is 3 e to the t. So that's my W. All right, step 4, I want to find V1 and V2. V1 is the integral of negative y2 f over w dt. That's the integral of negative e to the 2t e to the 3t over 3e to the t. That's the integral, let's clean that up, of negative 1/3 e to the 4t. All right, and finally we integrate to get negative 1/12 e to the 4t. Take your constant of integration to be 0. All right, V2, the formula is the integral of y1f over w dt. And so that's the integral of e to the negative t, e to the 3t over 3e to the t dt, which is the integral of 1/3 e to the t dt, which is simply 1/3 e to the t. All right, step 4 is to write down a particular solution yp. The formula for yp is v1 y1 plus v2 y2. All right, v1 was negative 1/12 e to the 4t. y1 was e to the negative t. And then I add on v2, which is 1/3 e to the t, times y2, which is e to the 2t. Now that's negative 1/12 e to the 3t plus 1/3 e to the 3t. So if I get a common denominator, I get yp is 1/4 e to the 3t. That's a particular solution. And then the general solution, recall how that works. You just add yp to yc. I've got yc above, so the general solution is 1/4 e to the 3t plus c1 e to the negative t plus c2 e to the 2t. Okay, let's do another one. Step 1 again is done, so I can determine my f of t. That's cosecant squared 2t. And so for this problem, I actually would not be able to use undetermined coefficients. I have to use variation of parameters because the driving function is not one of the allowed functions in UC. Step 2, I'm going to solve the associated homogeneous, and I started this out. I wrote down the characteristic equation. The roots are complex, and so my alpha is 0, and my beta is 2. And so I wrote down the corresponding YC, and for my fundamental set, I'll let Y1 be cos 2t, and I'll let Y2 be sine 2t. And then I take the Wronskian, which I already did in the interest of time, and you can read through that calculation. The Wronskian is 2. So now I'm up to step 3. I want to find V1 and V2. So I've got the formula for V1 there. That's going to be the integral of negative sine 2t cosecant squared 2t divided by 2 dt, which is the integral of negative 1/2. That simplifies to just cosecant 2t dt, and that's just a basic Bible formula. That's going to be positive 1/4 ln absolute value of cosecant 2t plus cotangent 2t. Okay, V2, integral, I want y1, which is cos 2t, f, cosecant squared, 2t, all divided by 2 dt. That's the integral of 1/2. And now that simplifies to cotangent 2t, cosecant 2t, dt. That's just, again, a pretty simple integral. That's negative 1/4 cosecant of 2t. Okay, step 4, yp is v1 y1 plus v2 y2. My v1 is 1/4 ln absolute cosecant 2t plus cotangent 2t. My y1 is cos 2t. And then I add on v2, which is negative, so minus 1/4 cosecant 2t. And then I multiply by y2, which was sine 2t. And then I can simplify that last term. So my yp is 1/4 ln absolute cosecant 2t plus cotangent 2t times cos 2t minus 1/4. And in this case, we were only asked to find a particular solution, not the general solution. So we're done right there. And that is the end of this section.